Formula One. It supports a multi-million dollar industry based on cutting-edge technology ranging from innovation materials, aerodynamic design, and sophisticated hybrid power units to even the material from which the driver's clothing is made. In the Formula One world, the most advanced communications and big data technologies are used extensively. It is the analysis of the vast amount of data generated every minute of the Grand Prix weekend that makes the competition so special. Without real-time data analytics, the F1 we know today would be very different. Hundreds of data points per second are generated in all key areas of the cars. Meanwhile, engineers and data analysts, both at the circuit and in the factory, thousands of miles away, compete to extract as much information as possible from them and weaponize that information in the fight for victory. What data is generated by Formula One cars? How is data transmitted by hundreds of sensors on the cars analyzed? How is the information obtained vital to reach the finish line a second or even a millisecond before the other racers? What data is generated at an F1 race weekend? Enormous volume of data is generated by each individual car during a Formula One Grand Prix. It all begins with stopwatches and chalkboards. Then in the 1990s, things progressed towards basic computers used to analyze the dozens of data points collected during testing before finally reaching the mass data gathering and real-time analysis used today. Formula One is a database industry and it has always been. However, it's only in the last decade that simulations have reached such levels of sophistication and speed that they can drastically influence the results of a test. Today, each car houses between 150 and 300 sensors, which generate millions of data points every weekend. In terms of numbers, around 300 gigabytes of data per car is generated each Grand Prix weekend. If we add this to the data generated by the rest of the team, it can amount to 40 to 50 terabytes of data per week. Handling this amount of data is certainly a demanding task and requires the most advanced technology for gathering the data itself, storing it securely, and for external communication, mainly with the factory and the engineering department. In addition to the computing power required for real-time data analysis is constantly increasing. That's why the different teams have partnered with companies specialized in cloud computing and data analytics. This means that the team is able to delegate part of the data analysis to its partners and focus purely on competing against the rest of the grid. Now, let us look at the win statistics of all the Formula One teams in the history of the competition. This is the number of podiums of all the Formula One teams in the history of the competition. Now, let us look at the 2021 season, which is currently going on. This table shows us the driver, their position, and the number of points they've scored, even with the percentage of points held by them. This table shows us the same for the different teams, the 10 different teams, and the number of points they've scored. These are the statistics which show the number of wins for the different drivers and the different teams in this season. These are the best jump statistics. They show the number of jumps, number of finishes, number of pole positions, drivers, and Grand Prix. Which Grand Prix? And this is the worst jump statistics. Now let us compare the two best drivers of this season just through their statistics. The two drivers are Lewis Hamilton and Max Verstappen. Max Verstappen is shown as the orange in the bar graph and Lewis Hamilton as the dark blue. These bar graphs show us their best grid position, best finish, their number of victories, the number of pole positions, number of podiums, their fastest laps, finish and points, and their different points. This is the data that's depicted in the bar graphs. Now, these are the different races in this season that have currently taken place. This table shows us the date, the location of the Grand Prix, the number of laps, the distance of the race, and the country where the race was held. Now, we will see a video on how Formula One can teach us about business and data analytics by Dr. Caroline Hangrove, CBE of McLaren.
So what can Formula One teach business about data? So I'm going to change a little bit the tone of the afternoon, I suspect, because I'm going to go into a little bit of the sport. I don't know whether we've got fans in the audience, but I'll explain a little bit where I'm going. One of the things I wanted to say is business. What I mean about business, I mean business with complex operations. Now, we often think that is business with complex operation. Of course it is. We've been drilling in the North Sea for the last 40 years. We don't drill vertically, we drill vertically and then horizontally. It's difficult. There's a lot of planning. There's a lot of data analysis done in order to prepare the next well. How do we do that? Well, we prepare, we do models, we have a plan. Another industry where they do that a lot is in air traffic control. Of course, they have to coordinate thousands of flights coming in, landing, leaving. They have operation, they have different KPIs. They have KPIs for on-time departure, leaving, misconnections. That's a lot to do in your head. So of course, you plan, you do models. And there's a massive link with F1. F1 is not just about a car going around the track. Well, it is, to some extent. There's a big team behind, though, that makes that happen. And other people forget that. Being an engineer that have worked 11 years on the F1 side, there's a lot of engineers doing this. Okay? There's one driver, but a massive team of engineers doing this. And one of the things that invariably happen, we plan our races very, very well, but things go wrong. And when things go wrong in Formula One, it's not going wrong like here. It may not have the economic or safety consequences that it has in an oil rig, but it's very public. Millions of people watch a Formula One race. So, you know, it's quite uncomfortable when things go wrong. So I'm going to give you an example of a few years ago at a Monaco Grand Prix. Now, Monaco has been on the Formula One calendar for years. And for those of you who don't follow Formula One, it's also one of the races where it's spectacularly difficult to drive because there's no runoff areas. It's a street. It's the streets of Monaco, cornered off for I guess 3 days of the year. And the story I'm going to tell you was compounded by the fact that it was pouring with rain. So a few years ago, when Lewis Hamilton was driving for McLaren at that stage, he started third on the grid on a pouring Monaco. And he had an amazing start, got into second place. Fantastic. Everyone was going, great, you know, we might just do it. We'd done loads of planning beforehand, all our race strategy done, and then this happened. On turn 12, over there, it wasn't just a puncture, he actually hit the wall, tire exploded. Right, no more right-hand rear tire. You know, in some way, it's great, the pit lane is only 15 seconds away. So he managed to drive his car back in without damaging the suspension. But on the flip side, it also means that you've only got 15 seconds to get your crew out and then decide what you're going to do. Because you need tires, and at that time you needed refueling as well. 15 seconds to do that, to plan, and then you get your car out again. Now, of course, I chose this example because we won the race. But actually, when you listen to the commentators on the television, they really thought this was the end of Lewis's race. Why is that? Because there was a lot of very difficult decisions to be made in the 15 seconds. Because, as I said, it was pouring with rain at the start of the race. But by lap 6, out of 78, by the way, at lap 6, the rain had eased off. So a lot less rain, track still wet. So what do? Do you stay on wet tires? Do you go on intermediate? Also, do you refuel to the end of the race? Whew. If you're heavy, you go slowly. But how many other pit stops do you need to do? Because every pit stop slows you down. And Monaco, as I said, is very difficult to drive. And therefore, it's very difficult to overtake because not much space. So if there's a race where race strategy is important, it's Monaco. So if I take a step back and saying, well, there was a lot of chances that we got the decision wrong, let's ask ourselves the question, why do we make bad decisions generally? Well, super scientifically, obviously. We say, generally speaking, actually, people who care, people who make the decisions, you know, people with authority and people with knowledge and information, there's very few people that actually are in that sweet spot, at least in the industries that we've dealt with. We may not be able to do much about the people who care, but we certainly can give more insights to people who will make the decision, people with authority. And in a data-rich environment, like this, like Formula One, we can do this. So of course, we didn't put our engineers in front with 15 seconds to make all these decisions. Quickly, let's run our simulation. No, of course not. What we did is we knew that there's only so many things that will go wrong. We keep running our simulations all the time with the new data that is coming in. If you've got new data, use it. Use it to prepare what your next best step will be if something happens. And of course, things like, if a safety car comes out, what do I do? We knew that the weather forecast had said it would stop raining. So you make all those different calculations in the background. We run thousands of simulations. And then we have a dashboard that helps the user who is on the pit wall make the next best decision. Now you might say, well, that works in Formula One because in Formula One it's simple. Can it work anywhere else? Of course it can. That first slide that I showed you about the drilling in the North Sea, we've actually implemented a system like that there. And the reason is that we have, as I said before, been drilling in the North Sea for 40 years. There's a lot of data that exists about that. There's a lot of models that are there. And these days, with AI as well, which we do, machine learning and so on, what we can do is analyze that data that is also coming in live as you're drilling and be able to give more information to the driller. Now, before we started working with them, the minute something went wrong, the driller said, the model's wrong. Because the model didn't expect to have, let's say, a pack-off or a Miocene gas event. That doesn't mean that the model is wrong. It might mean that you're not actually where you think you are, for example. They weren't re-computing their models as the new data was coming in. Now, it's not easy to collect data in the North Sea when you're drilling, so there's not a huge amount of data coming back. But use it, and they weren't. They weren't using the data live. That data, in fact, as was mentioned quite a bit today, that data was saved as a PDF and kept. Now, how can you do anything with that? So the first thing that we did is make sure that we could have access to that data live. Once you have that, you can then start looking at all those different conflicting KPIs that a driller has. They have to go fast because drilling in the North Sea is about £1 million a day. They also, the well integrity is super important because if you build it too tightly, and it breaks down, you have to close the well, you've lost even more money. And of course, what they want to do is drill where the density of the rock is appropriate. So and this is where the modeling comes in as well. But actually, there's only so many things that can go wrong, and you can use that data that is coming to give alternatives to the driller. And the point is not to say, we'll do automatic drilling here. We're giving opportunities for the driller to make the best decision that there is. So if I wind back to the initial question, can Formula One help businesses? I think that in circumstances, and the lesson learned that we've done 20 years in Formula One, is that you can arm the people making decisions by keeping your data up, by keeping your models and the decision support tool dynamic. You keep computing that, you arm your decision makers with the best information, the best insight, and the companies that don't make use of that, they put themselves in a really bad position because we think that if you can actually react to disruption, that's one of the main key to success for business. Thank you.